Welcome back. This is the second part of the first video, first module. We finished in reporting in the last video. Now let us go to the next slide. Mm. Here now we'll go through project selection and its models. Project selection is a process to assess each project idea and select the project with the highest priority. So first of all, we assess each project idea. So it is assumed that we already have more than one project idea. Then we select the project idea which has highest priority. Models of project selection. Then there are these models of project selection. Feel there are three types: numeric model, non-numeric model, and constraint optimization model. Numeric model, we have 10 models. Then non-numeric model, we have 6 models. And constraint optimization model, we have 5 models. So 10 plus 6, 16 plus 5, 21 models altogether we will discuss. uh, First of all, let's go for numeric models. In numeric model, we'll go for payback period, first of all. And in payback period, what is payback period? Payback period is a capital budgeting technique which refers to the time period in which the project will be able to recover its initial investment through the future cash inflows. In case of even cash flows, you can directly find out payback period. Now, let us understand what payback period is. For example, your initial investment in the project is 1,000 rupees, and you're getting 500 rupees per year. Then in 2 years you will be able to make out all your initial investment, and that is your payback period. And in case of uneven cash flows, again, the time period in which the initial investment is you will get back. So for example, you've invested 1,000 rupees, and in first year you're getting 1,000 rupees, 100 rupees, then second year 500, then 300, then 200. So the time period when you're able to recover the 1,000 rupees, that will be your payback period. Payback period is a non-discounting technique, means we are not using net present value method over here. No, we are not using time time value of money over here. And as far as payback period is concerned and decision making is concerned, the project which has quick recovery, means the shortest payback period, will be considered. So in case of mutually exclusive project, means only when there is only one project, then whatever management has decided maximum desired payback period, if the project is having less than that, the payback period, then it is accepted. And if there are more than one projects, then the project having uh, uh, shortest payback period will be accepted. So this is about the payback period. Now, discounted payback period, it is again, payback period is a discounted payback period is a capital budgeting technique which refers to the time period in which the project will be able to recover its initial investments through the discounted future cash inflows. So this is through discount cash inflows. So here we are considering a time value of money. So this is discounting technique, and what we do is we discount all the future cash inflows and bring them to the present level. Then we try to calculate in how many years we'll be able to recover back the initial investment, and that is our discounted payback period. And same as payback period, the project which is having quick recovery of money will be a quick recovery of initial investment will be selected. So discounted payback period is very similar to payback period. The only difference being, in the discounted payback period we are discounting future cash inflows. In payback period we are not discounting future cash inflows. So this is a time value of money based method, and payback period is not a time value based method of capital budgeting. Now, annual rate of return, very easy. It is like a yearly rate of return is calculated by taking the amount of money gained or lost at the end of the year and dividing it by initial investment at the beginning of the year. What you do is, for example, you've got net profit after tax for next 5 years. You make average of that. So you find out average net profit, and then you divide it by initial investment and into 100%. So you get annual rate of return, or this is also known as annual rate of return, average rate of return, accounting rate of return. And the selection criteria is a project having high ARR is selected. So This is there. Then next one is post payback profitability method. So in this method, the profitability of the project after payback period is considered for decision making. For example, there's a project which is which has initial investment of 1,000 rupees, and it is the future cash inflows will be 500 rupees per year, and the life of the project is for 3 years. So total 1,500 rupees it is making, and 1,000 rupees is the initial investment. 1,500 minus 1,000 is 500. That is profitability of the project. And if we divide 500 with initial investment, by initial investment, that is 1,000 rupees, that is 50% is the post payback profitability. So post payback profitability, it is when we go into decision making, the project with the highest profitability selected, it is calculated simply as post payback profit divided by initial investment into 100%. So this is the present value method. Net present value is a discounting technique of capital budgeting, which refers to the difference between present value of cash inflow and present value of cash outflow. So net present value is the difference between present value of cash inflow and present value of cash outflow. What we do is we discount all cash, future cash inflows to the present level, and then we discount the future cash outflows as well, and initial investment as well to the present level, and then we just subtract cash inflows, cash outflows from the cash inflows, and that's how we get the NPV. For mutually exclusive project, that means if there is only one project, then NPV with positive project, project with positive NPV is selected, and in case of two or more projects, projects with highest NPV is selected. So NPV should be more than zero. That is very important. It should be positive, and if there are more than one project, then a project with the highest NPV is selected. And then let us go for internal rate of return method. It is a discounting technique of project budgeting. It refers to the rate of discounting at which the present value of the cash inflow is equal to the present value of cash outflow. So IRR is R at which the present value of cash inflow is equal to present value of cash outflow, means NPV is zero. So the rate of return at which NPV is zero is IRR. And what is the decision matrix? If cost of capital is more than IRR, then we reject the proposal. If cost of capital is less than IRR, then we accept the proposal, and higher the IRR, better it is. So we always select a project with a better internal rate of return. So we'll discuss all these methods, quantitative methods, while also doing numericals. So just go through the basics of these methods. That is very important. When we'll be dealing with numericals, we'll deal with these things in more practical and in more detailed sense. Then let's go for profitability index method. It is very similar to present value method, NPV. And in NPV, if you remember, we used to do present value of cash inflow minus present value of cash outflow. In profitability index, what we are doing is present value of future cash inflows divided by present value of cash outflows. So it is just a division. And profitability index is a discounting technique because it is taking time value of money into consideration. And for mutually exclusive project, if profitability index is anything more than one, it should be selected. And for two or more projects, project with highest profitability index should be selected. And it is also known as benefit to cost ratio. Actually, in profitability index, what we are doing is present value of future cash inflows divided by present value of future cash outflows. And what we are actually doing is benefit divided by cost. That is why it is known as benefit to cost ratio. Then opportunity cost model. Opportunity cost is the benefit you forego in choosing one course of action over the another. You can determine the opportunity cost choosing one investment option over another by using one formula. So return on the most profitable investment choice minus return on the investment chosen to pursue. So whenever you choose any project, you always forego another projects because you have project alternatives. So what happens is you always forego a project, you always lose an opportunity because you have to select one. So whatever, whenever you want to find out what is the opportunity cost, you have to find out the return on the most profitable investment choice minus return on the investment chosen to pursue, or opportunity cost, what one sacrifice divided by one gain. Simply, basically, opportunity cost means the cost which a person foregoes while choosing one project over another, and that is what it is. Let us go for a scoring model. Scoring models may be more flexible rather than focusing purely on financials. Scoring models let you determine which qualities of project are more important to you, your team, and your company at large. You may, for example, choose to look at profitability, overall risks, support from stakeholders, and difficulty of the project. Once the criteria chosen, you will want to weight them according to your priorities and rank each project in terms of these four measures using a consistent scale. The total number of single projects are then combined and used to reflect the project's total value, making it easy to compare your project with to one another. Actually, it is simply a risk scoring model. You rate the different projects on the basis of various risks you are going to face, and on the basis of the score obtained, you choose the option which has least risk as compared to other options. Let us go for another option, that is another method, that is economic value added model. We have already discussed it. Economic value added is the measure of company's financial performance based on residual wealth calculated by deducting its cost of capital from its operating profit, adjusted for taxes on cash basis. So it is no PAT, net operating profit after tax. Net operating profit, how it is calculated, it is EBIT minus taxes. So net operating profit, EBIT minus taxes, minus capital invested into weighted average cost of capital. So this is overall cost of capital. And so what we do is no PAT minus overall cost of capital is economic value added. So this is how we calculate, and how what is the decision? How is the decision criteria? The project with the highest economic value added, we select the project on the basis of how much economic value addition it is doing. So the project with highest value addition, economic value addition, will be selected. Let us go for non-numeric models. There are 6 non-numeric models. Secret cow method. Superior decides the project and the team executes it. So boss is always right. Whatever boss says, they treat it as sacred cow and they just go for the project, and the team executes it. Operating necessity model. Some of the projects are very important for the operating necessity, as operating necessity for the firm. Without them, they cannot operate. And for example, if a firm is lying in a earthquake prone uh, situation, geographical place, then what they can do is they can take certain projects to minimize the risk caused due to earthquake. And that is where operating necessity, that is the operating necessity of the firm, and that is how operating necessity model works. Comparative necessity model, the project is essentially to survive the competition faced by the firm. You're taking a project only because your competitor is taking, and if you don't take it, then you will be lagging behind in the competition. Product line extension model, the project is essential to extend the existing product line of the firm. So what you're doing actually is you've already been working on some product lines for quite a period of time, and now you want to go ahead with the extending your existing product line. Then you can go for this model. Comparative benefit model, the project is selected because the project is comparatively more beneficial than other projects. Q-sort model, it is very easy. What you do is, according to the relative merits of the project, are first divided into 3 groups: good, fair, and poor. Then the main group is further subdivided into 2 types: fair minus and fair plus, if any group has the more than 8 members. And then on the basis of these rankings, then they're ranked from best to worst, and then the model, the project having belonging to the good category and the fair plus category is selected. So it is basically a ranking model. Now, constraint optimization model. There are 5 types of constraint optimization model. In this, why it is called as constraint optimization model, because we are constraining some resources which are available for the project management. Now, if let's go and look into these models. First one is linear programming model. This programming model and method involves bringing down the cost of the project through reduction of the time required to complete it. So according to this model, there is only one variable which decides on the cost of the project. project, and that is time required to complete it. So you try to reduce the time required to complete it. You try to finish a project within minimum possible time, and that is how you reduce the cost of project. Now, the nonlinear programming aims at solving optimization problems wherein some of the constraints of functions are nonlinear. So there may be more than one functions. Now you're considering more than one variable, and you're trying to manage those variables to reduce the cost of your project. Now, integer programming. This method focuses on integer value rather than fractional values. Some products like table, for example, can never be fractional. So you always consider integers. You ignore fractionals, and that is how you do. So you do it in rounded figures. And dynamic programming, this involves simplifying a complex problem by separating it into a number of simpler problems. So what we do is we divide a complex problem into many smaller problems, and then we try to solve these problems according to this model. Then multiple objective programming. The multiple objective programming approach focuses on making a decision for a number of problems using mathematical optimization. So what we are doing is we are taking multiple objectives, and then according we make a mathematical model, and we place the figures, and we find out which project is least at cost and more on benefit, and then we select on the basis of this. Thank you. I hope you enjoy the first unit. Now we'll see you soon. I just go through these videos. Thank you.